So first video here is going to be over so this is in the file that hopefully most of you of organisms you're going to, on your calculator, open spreadsheets, and then type your numbers from the table. So I already went ahead and did that. I'm also going to show you a very common mistake. Let's say that you're here and it's still blinking, and you do your next steps. So your next steps will be Control Doc, okay, and then that and statistics. You go here to X, and then Y, and then right here you go Analyze Regression, okay, and then Exponential. That's a very common mistake. All you have to do is click Escape. You go back. You see that's blinking, I didn't enter it. When I enter it, it's on blue and that one's not blinking anymore. Then I can go back. So that's just a very common error. I want to show you here. Remember is function. So y equals 28, and this is single cell organism, so I'm going to round, and actually it's 28, so I'm going to round 9. Okay, because it's whole numbers. At least 3 numbers after the decimal, round the last number. Okay. Alright, I skipped letter A because we talked about this response for quadratic. Is a table linear? And we said no, there's no constant rate of change, and it doesn't look like a line. So this is the same that we investigated before. Okay, so we have our exponential model. Next it asks us if and to use a correlation coefficient. Correlation coefficient is the R squared. So I'm going to go to 1.1. I'm going to go back to C1. Common error is if you click it too much, it out, it doesn't let you do it. That's because that is blinking. So you want to just have the blue highlight. Then you go to Menu, Statistics, Start Calculations, and then go all the way to Exponential Regression. Okay, over here, you select from the down menu the X for X and the Y for Y. Press OK. It will give you all of the regression, that R squared, and it's 0.99466. You can just 0.99. So it's pretty much a perfect fit. The correlation coefficient is 0.9, which is to the perfect fit of 1. And class gave us exactly the one we did with the bacteria. It gave us exactly range. So domain is my X value. In this case, is time in hours. But we don't know when it's going to end. Because we said in class, this is an exponential model. So exponential model, because of the horizontal asymptote, which in this case would be 0. It keeps approaching it, but we don't know, and it keeps getting closer and closer and closer to 0. We don't know exactly when it will stop. So I don't know from a mathematical model, because I don't have the real life data, time would be greater than or equal to 0. Okay, or you can put hours is greater than or equal to 0. For range, for my range here, this is a number of organisms. Growing, again, I don't know when it's going to stop, right? It goes from 0 and it's going up and up and up if you graph it. So we don't really know when it's going to go on. We know that, let me go back over here to time. It says 16 hours. Okay, so, but this is just absurd for 16 hours. It is not, we don't know when it's going to stop. So I just wanted to clarify that before we moved on. For the range is a number of organisms. We know that we start here, we start at 29, but we don't really know when it's going to stop. Okay? The same thing here because it's growing. If it were decaying and we started from 29, we know that it's going to decay until in real life it's 0. For here, it's going to go on and we don't know when it'll stop. Okay, so here the number of organisms would be number of organisms. It just keeps growing exponentially over and over and over. And this will be greater than equal to the 29 that we started with. So from 29, it's going to go on forever and ever and ever. Now, if here was a little bit more specific, the problem is just saying that only that this experiment only happened for 16 hours. Then we would say 16, and then we and then we would put it here. But it's not very clear on that. It just says that they measured it for 16 hours. Okay? So when it's growth and exponential, we only know the start forever. We don't know when it's going to end. Same for this. Okay? Of the base. So the base would be which is 29. B, this one is a rate, okay? So this is a growth rate. B is 1.145, which is, B is 1.145. Was given by 100% plus rate, and that was a growth factor of this, the 114.5%. So now we know that it was growing by 14.5%. It means organisms 14.5 per hour. Okay? Because it's growth. In the context of the number of organisms. So we can already set that. The y-intercept is the A, remember? So whatever we set for A, this is what we set. The y-intercept is 29. Which is the initial value of organisms. Okay? Using the exponential model, what will be organisms after 1 day from when the experiment was started? So 1 day, remember that we're measuring in hours, so 1 day would be 24 hours. So I'm going to use my math model. But instead of x, now I need to x 12 hours, so to the 12th hour. So this is where I use my calculator again. I go to the home button, I go to the calculator, and I type that exactly as I see it on my paper. Squared, this one, that gives me the exponent, to the 4th power. And this would be it, and I round to the nearest whole, so 748. Okay, 748 organisms. Okay? Alright. So, a little bit harder to make sure that you know is your growth or decay factor, in this case a growth factor, and so make sure that you can calculate the actual growth rate or decay rate for the decay. So this is at 100%. Mention that on the exam. Okay? For the domain and range of this growth, we only know the starting point and we don't know when it's going to end. It just keeps going up and up and up in exponential function. They want for you to do it in the context of the problem, so you can write time or you can put hours are greater than or equal to 0. Here you can do number of organisms. Okay, so instead of using X and Y, you would do whatever the problem tells you to use. Alright, so this is the free response part of your exam. It's going to be similar to this. Make sure you know how to interpret all of that. We're going to finish this video and then I'm going to make a multiple choice.